Yeah. All right. Well, here's one for us. Is the business of robo-taxis just dead?
Man, that is a good question, right? I think if you're looking at the latest data, and
I wasn't. I was just asking the
you were just
question.
making stuff up.
Yeah, just look, Waymo has been at it for 15 years, right? They got deep pockets behind them with Alphabet, and that is one of the things that make it possible, right? When you look at the most recent news of last week, Cruise, GM owns 90%, and they want to claw back up to 97%, right? They just shut it down, right? So they shut down the number 2 in some ranks, robo-taxi business. That means, GM for the past 10 years put in $1 billion a year. It was just a money pit, right? So that's $10 billion. Now, GM's a big company, but they're not a big, like a tech company, right? Like Alphabet or Amazon.
Yeah.
So is it dead? I don't think so. I think it's much bigger problem than what people had originally thought.
Yeah.
5 years ago, everybody was like, "Oh, it'll take 5 years." No, it's going to take 15 years.
It's always taking 5 years.
Right.
Yeah. We'll have that. Right. We'll have robo-taxis in the next 2 years.
But having said that, so I know I've followed Waymo since almost the beginning. And as you said, they've got incredibly deep pockets behind them, but that's allowed them to have an incredibly smart strategy where they've gone really slow and steady. And I think that seems to be paying off now.
Yeah, I agree. Sorry, Sean, but when you look at, GM, for example, I think it was maybe 2 years ago, they're like, oh, by 2030, Cruise is going to be turning $50 billion in profit, right? Where you never heard from Alphabet saying, Waymo is going to be turning this much profit by this time, because they didn't have to, because they have deep pockets and they can subsidize that for much longer, have this methodical approach to it, more careful, less, the whole move fast break things in, the Silicon Valley. Here, it's a little bit different, right? So you're not necessarily trying to do that when people are involved.
Just move slow, try not to break anything.
Right.
I will point out that is a much better motto for an autonomous vehicle.
Right.
Please don't break things, because those things tend to be people. Well, it was funny too, because I was looking just at some of the headlines, right, around, because I thought it was very timely for us recording this podcast with the GM. I like the way that they're using it, right? The headline writers, they just do a good job. Right. GM blindsides Cruise. They shutter the door. But yeah, 10 like a $9 billion loss basically.
Right.
And so, we'll talk about this later after we actually officially start the show and all that stuff. Yes. But one of the things that I'm always curious about, and Andrew I think knows this too, from what comment I made earlier, is I'm like, all right, so is that a $9 billion investment in the technology and the industry?
Yep.
Or did they literally just light $9 billion on fire? Because I will point out, it does not take $1 billion a year to run Modem Futura, and some of that money could have come this way. Is all I'm saying.
No, I don't. I wouldn't consider it Bernie, right? Because if you read the statements from GM, right, what they're doing is they're shutting down the robo-taxi business, meaning they spent the last 10 years developing technology, sensors, the software stack, right, that could be very useful on a level 2, level 3 autonomy vehicle, right? So, no, I don't think they burned it. I think it's the chase of the robo-taxi to level 4, that's gone for them, right? And I think they're going to leave it to the, the Waymos and the Zooks, people with deeper pockets. But I think it's very transferable where, it's the same technology, same idea behind it. Now with the level 3, the difference being that, you hand off control to the vehicle, but within, I think it's 10 seconds, if the vehicle tells you, you have to, grab back control, they give you 10 seconds to do that, right? Where at level 2, you're always engaged. But if you think about like what, Cruise was able to accomplish, they did have several, millions, I think, miles of fully autonomous. When you transfer that to a level 3, that's a really solid level 3 that, I can give, control back within 30 seconds or even, so that I think it's very transferable and applicable. I don't think they burned it. I think the whole scaling the fleet and bringing it, to the streets. I think that's money that they're not going to see return on. But once they start applying that software stack and whatever learnings they had on the sensor and the hardware side, that's very, very transferable to the level 2s and level 3s.
Yeah.
Yeah. Well, and it's interesting too. I mean, also Cruise has had, unfortunately within, I think the last year or last 2 years, certainly has had, some major issues with, accidents basically with other objects. But then there was a famous tragic incident where a pedestrian or a rider who got out, or a pedestrian on the street, I can't remember the circumstance, was essentially dragged by one of these cars. And so some really, also, I mean, you can see like if you're GM and you're doing these kind of things, I mean, it was kind of like stacking up where this is not looking good.
It ended up being, I think, another vehicle hit the pedestrian. The pedestrian got thrown in front of the Cruise.
That's right. Then it was dragged along by the Cruise. Yes,
exactly right. The Cruise didn't have, I guess, sensors under you know what I'm saying? Like, I think it noticed something on the wheel speed or traction,
which just
something.
shows what the learning curve is like. I mean, nobody thought to put sensors underneath the car until somebody got trapped underneath it.
And to be sensitive too. I mean, obviously this was. I can't remember. Did the person involved in the incident, did they die in the incident?
I don't think so. No.
Okay, so that's better at least. Yeah. But I'm like, let me just point out how horrible it is where the only way you're detecting that it's dragging a human is based on wheel speed. That's, oh my goodness.
I mean, that's what happens when you have the public being part of your beta testing, right? I mean, it's
right.
You're not in a closed environment. You're in an open environment of the busiest city, San Francisco, right? So you're subjecting the public to something like that, which, it's a way to do things, right? Like that's I don't know about a wrong or a right way, but I think there is a more safety critical approach, kind of like what Waymo did, getting, being in Arizona first, right, with easier streets to navigate, less of a crazy traffic and people walking on the streets, right? Where Cruise's thing was, let's go in the hardest one. When we figure that out, the rest is easy. You know what I'm saying? That's truly like a way to look at it.
And I think this is one of the big challenges, and something that I think we'll sort of dig into sort of once we get through the cold opening, that with technologies like this, there is that problem of beta testing on real people in real environments. It's not like beta testing software where if everything goes pear-shaped, you can just reset.
No. Or even under normal 100%. Research and university study. I mean, we talk about this a lot. Right. And this is something, I'll say this, we'll pin this, and we'll actually start the show. How about that? But that's one of the big challenges, right? With this type of sort of public or corporate sort of research that's happening in public, that these are not behind, like the rest of the cars, the rest of the pedestrians that were on the street. We did not agree to or sign up for whatever this research experimentation is.
Yep.
And so... and so we're subjected to it.
Yeah, because the cities that are Arizona being not Arizona, but Phoenix and the surrounding areas, and the Arizona governor, they all wanted to be in the forefront. So they all looked at not deregulation, but like not being as strict.
No, so creating that sandbox so people could experiment in it. Yeah.
So you drive that talent to your state and city. Yep. And then you get jobs and all of those things that politicians are, always chasing after. And but you didn't agree to it, but the people that were voted in by the constituents did.
When you put that tick mark on the ballot paper, you voted for it. Right.
Yeah,
you didn't know, but
in a way. And I suppose when you ride in a Waymo, you agree to it. I mean, you're right. But that's it. But it's a challenge with these things, and it's not alone. I mean, there's AI, all these other things. I mean, same thing. They're experimenting in the wild along with stuff. All right. I'm trying really hard to try to keep my cold opens under
10 minutes?
I think the record was like 15 or something. So we're already good there. So we'll take a quick pause. We'll let our intro music play, and then I will introduce our special guest who has joined us today.
All right.
Initializing waveform.
Modulating signals for transmission.
Exploring the possible, probable, and preferable futures.
Welcome to Modem Futura. And there we are. Andrew, thanks for joining again. As always,
Sean. Yes, always
this is so much fun. So Andrew is here. Sean is here. That means this is Modem Futura, the show that explores the intersection of technology and the possible, probable, and preferable futures, asking deep questions like what will it mean to be human in the future? And today we are joined by a very special guest, Brunno Moretti. So, and before I even read your bio, I think I have to disclose the fact that you and I have been friends for more than 20 years.
That's correct.
Which is weird. I was like, is it 24? I'm like 23. It's like 23 years, I think.
Yeah.
If I get the
college,
dates right.
Early
we go all the way back
me,
to Michigan State University Computer Store. So we go back a long way.
Yeah.
But this is an absolute thrill. One for me personally, just to have you on the podcast, because our professional lives never seem to get to overlap like this. So this is really fun.
No, it is. I think, you've stayed in academia, right? I've been in the corporate world, and, we always chit chat about things and your work, my work. And then we never found this intersection. And I think once you launched this, and I've been listening to it, which great job, you guys.
Oh, thank
you. It is
we'll pay you later, but thank you.
Yeah.
I already did. Apple paid them before we started.
But, the point is that, what it is to be human in the future. And I think the area that I work in autonomous driving and ADAS and other things in the automotive industry will have, and you guys already covered once before, but, will have a deep impact on what it means to be human in the future, right? So there's a lot of implications there. So super excited that, our paths are crossing here professionally. So, love to have the conversation.
Yeah. And now we'll see if our friendship will survive the test of a. All right,
bring it on.
Let me read what I have for your bio, and then you're going to have to explain, because also.
Okay.
So Brunno Moretti, you are the president of ADAS Solutions for Ascential Technologies. Prior to that, before joining there, you worked for Ascential Technologies as senior vice president for product and commercial operations, and worked with the near-range LIDAR business and all that kind of stuff. And previously, you've had positions in GM. I don't even know how to say this. ZF Friedrichshafen?
Just say ZF.
ZF. Okay, at ZF, and also at Uber as well. So it's a wonderful treat for us again to have you join us today too, because we're talking about autonomous vehicles and systems and all that kind of stuff. And it's wonderful us to branch outside of academia and pull someone in who's been in that corporate professional experience for quite some time. But here's where I need your help, Brunno. Right off the bat, your title has an acronym in it. What on earth is ADAS? What does that even mean?
Advanced Driver's Assist System, right?
Okay.
So these are the cameras and radars, sometimes LiDAR, and other sensors that would enable features that enhance and act almost as a co-pilot, right? Make sure that there's no autopilot in there, because it's to support the driving. So features like automated emergency braking, lane keep assist, rear cross traffic alert, things that will intervene if something is going, array, like you're about to hit a vehicle, or that's more on the safety side. ADAS also falls into the convenience, right? Where level 2, or level 2 plus, we can get into the definitions of those, but those allow you to take your hands off the wheel, feet off the wheel, but still engage driver in the loop, eyes on the road, right?
Right.
Then there's a level 3, which allows you to disengage your eyes, but then to have the ability, the vehicle has to give you a warning and to a certain point of time and say, hey, you need to take over. That's a level 3. And then a level 4 is a geo-fenced autonomous,
that's the Waymo.
Driver.
Yep.
That is the Waymo.
Yeah. Awesome.
And then level 5 is the Utopia.
The Waymo with no
anywhere,
restrictions.
It just can go anywhere without pre-mapping, without geofences, anything, right? That's a more futuristic look.
I've got to ask you about the assist levels, all of those things that we now find in vehicles, and I think some of them are now legal, that sort of keep you on the straight and narrow, the sort of lane sort of drift centers and things. am I alone in getting really irritated with these? And I'm being a little contentious here because I know these are important in terms of saving lives, but I've got to be honest here. The last thing I want when I'm driving is the car telling me what I shouldn't be doing.
Right. Look, it's a very valid point. I think that the take rate and the usage of these features have gotten better. I just saw a stat today that said that 10 years ago, or I forget if it was 5 or 10 years ago, that 50% of people would turn off those assists because of that.
Yep.
Today, 9 out of 10 keep it on.
Actually, that's pretty good. Yep.
So that's for the lane keep assist as an example, right? So that's there's lane warning, lane departure warning.
Yep.
That is the beep beep, you do something.
Yes.
And then the lane keep assist is the, hey, I'm going to nudge you back in.
It takes over. And that's the thing that I can't cope with. And I think it's because I've grown up believing that I'm in control of the car. So when the car starts doing something which feels counter to what I'm trying to do, it throws me. But but by the sounds of it, people are getting used to this.
Yeah, I think the more penetration that you get into vehicles, which it's something like all new vehicles, 90% of all new vehicles have some level of ADAS, right? And there was a commitment by the OEMs, no regulation, even though there is regulation coming in 2029, which we can get into it as well. But there, with no regulation, it was a gentleman's agreement or whatever you want to call it between the OEMs that they're going to do that.
Yep.
So that's AEB, right? The automated emergency braking. Some lane keep assist, rear cross traffic, or the rear virtual bumper, the one that as you're backing up, it sees something and just stops for you so you don't hit something, right? So
it's funny. So I mean, just hearing you describe it too, it raises a question from my mind, Andrew, because I'm likewise. I think we talked about this back on our Waymo episode too, because we have in one of our cars, we have one of those lane. I forget, Brunno, it's the one that just tells you when you've crossed the lane, but it's often wrong. It does the false positives all the time. Cause they do like the patchwork on and then the light hits it at a certain rate and it's like beep, beep, beep. It's constantly beeping at me. And so I'm part of that old group. I turn everything off, but I can't turn that off. The other one is like the automatic start stop thing drives me insane. If you've ever had battery issues or an alternator trouble, it's traumatic. And so like, you're like, I jumped this thing. It's running. If this thing dares turn off at an intersection, it's dead.
I'm exactly the same with that one. And I now own a car where I cannot disable it. I mean, I've got the button where every time I get in, I can switch it off, but I have to do it every single time.
And so Brunno, so when you say that statistic that you heard like today, 90%, I'm like, I would be, the follow-up here is that because you just cannot turn them off? Because, it's just hilarious. Because I same thing. I'm like, I would rip it out with my bare hands if I could. But I do wonder though, like maybe
you realize you came on here to be roasted. We're going to dump all of our issues.
Hey,
this is all your fault, right? Bruno. Every time that light thing goes off, you get a text from me. Bruno!
Yeah. And look, it's I think that was 9 out of 10. I think it was when it is available to be turned off, because I think the ADAS systems are still optional in a sense that you can turn them on and off, where the start stop, the way that the vehicles are run for emissions and fuel economy, if they allow you to turn it off, that means that when they do their testing for emissions and when they do their testing for fuel economy, that means it has to be on. That means they get worse numbers, right?
Yeah.
So some OEMs will then turn off the ability to do so, because then they get a better rating under the window sticker.
Yeah.
So that's a little bit.
Can I ask you a weird question? So I have a suspicion about something. When you see on a car and it says P0, like partial zero emissions, aren't all cars partial zero emissions when they're not
PZAV?
on?
Yeah.
Or whatever.
ZAV and PZAV, right?
Is that what that is? It's just
it's hybrids.
Okay.
It's hybrids.
Right.
Yeah.
We're just not burning gas right now. So look at that. We're perfectly zero emissions.
Sitting in the garage doing nothing. Yeah, that's zero.
Zero emission.
No, the PZAV is when you have a hybrid or a plug-in hybrid.
Right.
Before ADAS, I did a lot of work on EVs as well. So, I spent 10 years at General Motors, and, my first few years were all in the Chevy Volt, Chevy Bolt. So, what does that mean? And I did talk about those stickers a lot, because it depends on the state. You get that HOV access lane if it's a PZAV or a ZAV, right? Which is partial zero emissions vehicle or zero emissions vehicle, right?
Yeah, here in Arizona, those are we have cloud plates, and those are a hot commodity because those get you that coveted HOV access during rush hour when the
but just going back a second to looking at how the industry has brought in a lot of these things. I was actually listening to you thinking this is pretty impressive because, as you say, up until sort of between now and 2029, this is voluntary. This is car companies deciding to bring in safety features because they've both all agreed together. But I'm also assuming because they see that it's the responsible thing to do. And that makes it such a nice example of what we might call sort of soft law and soft governance, where you actually have the industry doing the right thing, being responsible without regulators slapping them across the wrists at this point if they don't do it.
Very good point, right? I think there is a couple of things where, one, it is a competitive advantage sometimes. So some people are looking for, hey, I'm buying this for my 16-year-old. I want to make sure it has the latest and greatest, ADAS features because it could prevent an accident for my kids. Or even for myself, I want to make sure, I live a long life.
It's like the Volvo mentality. I want the safest car, designed with safety first as its like prerogative. Yeah.
So there is a commercial incentive for them to do that because it can be a competitive advantage. But there is a level of, they had this agreement of like, let's put these in because it is the right thing to do. It is technology that could save lives, right? And then in that balance, Andrew, that you talked about with, self-regulating or being regulated, when you talk about 2029, which is it's FMVSS 127, that is the mandate from NHTSA, that all vehicles as standard, they have to have this AEB, right? The automated emergency braking.
Yep.
Now, the difference from that mandate and the OEMs fought that mandate very hard because today's vehicles, AEB, work between 25 miles an hour to maybe 45, depending on the OEM.
Yep.
This new standard is going to be up to 62 miles an hour and be able to engage it at 90 miles an hour, right? So,
So like highway speeds and reckless driving speeds, basically.
Right. So NHTSA didn't think it was enough what they were doing because there are other situations that, the current system would not be able to handle because when you look at the systems today at those speeds, they are using normally, right, one front-facing camera and one radar. Right. And that camera, it depends, right, on a whatever, but it's usually between 1 to 3 megapixels, right? And then it has a compute system embedded into the camera that allows you to give you perception and then an object level list that they're going to send it out to the vehicle. Then the radar does the same thing. It detects the object, classifies it, and then sends it to the vehicle compute. Then they will do a high-level fusion. They will fuse those outputs from the camera and the radar, and then determine if they have to do the vehicle to stop, right?
Right.
When you look at going to speeds at 62 and 90, and the mandate also has a pedestrian AEB, right? Which then it's pedestrians are harder to detect because the radar cross section is much tougher,
smaller.
For the radars.
They're squishy and soft,
right? And also the other thing that the mandate does is you have to run these tests at night. So if I have a pedestrian that is walking at night, the radar is going to have a hard time because it is a pedestrian with a smaller RCS, radar cross section. And then the camera, because it's at night, even with the headlamp, it will have limited visibility, right? So the OEMs were upset about that because it does mean they're going to have to implement new technology. Now, at the forefront, the latest I checked is 8 megapixel cameras, right? And what they're called imaging radars, which, a radar has a mimic chip, which is like what creates the waveform that sends it out through the antenna. Normal radars today has one mimic. And then these more advanced called imaging radars, they have 4 mimics, right? A regular today with 1 mimic.
Does that make it like in an array rather than like one single like antenna or something to try to bounce back a more high resolution blob?
It enables you to give elevation, because today's radars do not have elevation
So
separation.
just bumper level or whatever.
They only have azimuth, right? So they only go on side to side.
Yep.
So for you to have this 4 mimic, an 8 megapixel camera, the OEMs are upset because it costs more money.
Of course, yeah. But also, hearing you say this, it strikes me that there must also be risks. So you're now looking at an incredibly high level of technology for cars that are going over 60 miles an hour. What happens when the system misdiagnoses something in front, so it slams on the brakes when it shouldn't, or doesn't detect something that it should? What happens to the car behind you? I mean, are there the risks of cars being rear-ended because the computer has decided to slam on the brakes? And if that happens, who's liable?
Yeah, no, great question, right? I think there is probably a higher risk of that happening today because of the quality and resolution of the sensors today, right? But, the false positives is something that early on when ADAS first came out was an issue. But I think they've figured it out, really with that fusion, especially when you have two sensor modalities looking at the same area, you're going to get a better, higher level of confidence that minimizes a lot of that. But it doesn't mean that it can't happen. Yeah. And if it does happen, there's a big question
I said,
of who is liable.
That's like the, right now the lane detection just beeps and is annoying, but it's not slamming on the brakes when it sees, again, a false positive. But Brunno, I'm just a little bit sort of taken aback by a 1 to 3 megapixel camera. Like that's 2005 camera.
Not an automotive.
I mean, it's for anyone listening.
It's a little bit like the space shuttle. You're about 30 years behind.
That's right.
Yeah.
I mean, for anyone, to put that in perspective, that was like the original iPhone camera.
Yeah. So I've dealt with this so much, right? Because when I worked at GM and even ZF is one of the suppliers for the automotive industry, the supply chain that gives you the cameras, right? So there are Omnivision, Sony, they make automotive grade sensors, right? Image sensors. And for whatever reason, it is really hard to develop something that can last between negative 40C to plus 85C.
Yeah.
Right?
Yeah.
So that's the automotive standard, right? So, you guys are even more than that.
Right, yeah.
Yeah, but the point is that, that design parameter puts a strain on the ability to give you the same things that consumer electronics do. And I had so many people ask the same question, right? They're like, my iPhone does whatever, 16 megapixels. And, we're stuck at this. But when you think about it, right, like in today's vehicles, most of these cameras are monochromatic, right? So they're only looking at a grayscale image because you don't necessarily, need to see the colors because you're just trying to see the discrepancy between the white and the black. And is that a line? Is that the contour of something, right?
Yeah,
so
the contrast of a shape or a person or an object or something.
Yep. So, and that gives you way less need of a compute, right? That's the other thing that once you go to these higher resolution sensors, you need a very powerful compute, which is very expensive, as you all know, right? Especially when you're doing things real time.
Yeah, but I think this is such an important point because it goes over the head of many consumers that if you're looking at designing to a spec which is going to ensure safety over a long period of time, you can't afford to go with the latest technology because that's where you're going to have the greatest number of failure modes.
Yeah, and it will not make it economically viable for these OEMs to put it into the vehicles, right?
Yeah, if you're putting in a $1,600 iPhone in the bumper. Right? Well, it's funny because I was thinking about that. And then so one of the things I was thinking about too, in just knowing we were having this conversation today, I was thinking, I'm like, it hasn't happened in a while. So I think the phones have gotten a little bit better. But even out here in Arizona in the summertime, it would not, if your car was parked outside, so it's, just subjected to ungodly heat and internal temperatures, right? I mean, you look it up, people bake cookies in their, inside their cars and stuff. It's ridiculous. But how many times, for example, like the iPhone would turn off because it would overheat just by being in the car, which is always great when you're driving. You're like, I need directions. And it's like, you get the flashing thing, it's melting down. But what made me think about that too is this the challenge of when things go into these automobiles, like we live this firsthand. We eat car batteries out here like crazy because the heat just destroys them. Again, leading into my trauma about why I don't like the auto off start stuff. There's a story there, but it's crazy the range of survivability that technology has to go into in terms of, places where the deep Arctic freeze sort of a thing. Yeah. And then here in the Phoenix in the Valley where things are literally like the rubber is just rotting from the sun and the heat. And how that keeps these things in play, because one of the things that then I'll transition this to kind of move us to a slightly different topic, but related to this issue is this idea of as these cars become more and more sophisticated, and we're moving from those levels, right? Those levels of autonomy, and it was 1 and 2. And is there any level 3 for sale? Like, can you buy a level 3 car today?
I know Europe, Mercedes got approval. I think they got approval for a vehicle in the United States.
Okay, so
but
barely.
It's like a super low speed, like up to 30 miles an hour. Traffic jam assist.
Okay, so mostly it's level 2 that's available for sale. But follow the progression here. We're headed that way, and I don't need to get back into my complaint about Tesla's advertising full self auto and all that kind of business.
Driving, yes.
But they're a square, like, I'm correct, Brunno, right? That they are squarely a level 2 car that's pretending to be a level 3 in many ways, right?
Which one specifically?
Like the Tesla, the ones that say they have full self auto. That's a level 2 pretending to be more than that.
Legally, they say they're level 2 because legally they cannot claim that they're level 3, and they wouldn't want to because they could get into all sorts of trouble, right? So if you look at the documentation, they do not talk about it. But if there is documentation, then you see that
it's a little bit like health supplements, where you're not allowed to make a health claim, but you sort of you fudge around it so it feels like you're making a health claim.
Exactly. Yeah. All right. So my question, though, where I was where I was trying to take this in a very long, I was taking the back way around to get, but as those cars, the technology that's in them, as we progress towards more sophisticated level 2, if you want to slice that up and call it like a 2.5 or whatever, but as we get towards those level 3 places, I'm just really curious to hear about this idea of like cameras and compute power. Like, we just spent some time talking about that, versus LIDAR as these things are using these things. And Brunno, if we can tap into your expertise a little bit too, and maybe if you could explain a little bit first about what, I think people can understand the camera systems, but maybe explain a little bit of like what LIDAR actually is, and how it's different from camera systems. And then, because I think that's a really fascinating thing, because my understanding is LIDAR is way more expensive and way more difficult and way more sensitive, yet much more accurate. Tell us what LIDAR is, Brunno.
So LIDAR is light detection and ranging, right? That's what it means. And basically you have...
Our iPhones also do that too, don't they?
They do. They do have a LIDAR. It's mostly to take pictures, but...
That's how you do that's how it does the face scan, right? Is with like front, a LIDAR?
And then they also have a LIDAR in the back that you can use whatever apps to like map your whole room with accuracy of a LIDAR. But it's an active lighting system, right? So camera's passive. You just open the shutters and the information from the world comes in.
Is it use infrared? LIDAR, is that how it doing? It
depends on, it's 905 nanometer or 1550, so 1550 nanometer. Those are usually where the industry kind of converged, 905 being a little closer to the visible, which, makes it subjective more to sunlight noise and a few other things. 1550 is farther in the spectrum. It's less accessible to that, but it also doesn't do very well with water, right? So it's one of the things that, it's eye safe. Both are eye safe, but people claim,
especially with your Face ID, you're not burning. Right. Well, it worked one time.
You're getting me paranoid now. My phone is beaming stuff at me all the time.
Oh yeah.
Yeah. Being both of them being eye safe, but 1550 normally you can push more power to it because as soon as it hits, your eyes, you have this layer of liquid, right, that will stop it from being damaged, right? So they claim they can go farther. For the most part, that's somewhat true, right? But the point is that it's an active source of light using lasers in either of those frequencies and wavelengths. And, you shoot it. There is two ways of doing it. One, the most common one is time of flight, right? So you're shooting it and counting the seconds until it comes back, right? To know what the distance is, the speed of light.
Yep.
The other one is FMCW, frequency modulated wave, continuous wave.
Sounds good.
Yeah, that's basically.
You could have made up anything right there, and I've been like, yes, SFM WXY10. Yes, got it.
FMCW, yeah. It basically just shoots a continuous laser beam, and then as it changes locations and other things, you look at the phase shift, and then you're able to detect the distance. And that's very similar to radars. Radars use FMCW as well, right? But the LIDARs it's an active light source, which then, again, if you're at night, you're able to get very good performance because it doesn't care if it's, dark or light or whatever.
Right.
So it's able to do that. But then you usually have some sort of steering mechanism that you're shooting the lights, and then it steers it, and it creates this field of view that creates what they call, the industry calls a point cloud. So it's a 3D point cloud. Every little dot has XYZ, right? A location as referred back to the home base, which is the LIDAR. And that allows you to do a very, high definition, very dense point cloud that allows you to detect the surroundings of the vehicle much better than some of the other sensors, because it gives you distance, right? So that's something that a mono camera can do. Stereo can, but tech's not there yet. And then the separability between targets, because their resolution is 0.05 degrees by 0.05 degrees, right? So that allows you to, detect a child next to a car, next to a soccer ball, right?
And recognize all those objects. It doesn't flatten them as just like one visual outline or something.
Yeah. And then you have the radar has a separability of about 1 degree, the good ones, the imaging, more expensive radar. So you can see that, if a child is standing next to a vehicle, even an imaging radar might just be able to detect one target. And then you can't really, if you classify it as a vehicle and that child moves, then you're not tracking and trying to predict the movement of that object, which then could cross your path, right? So the LiDAR gives you that extra boost of resolution.
Right.
And in different scenarios, it enables you to have, a rule of thumb, and there is no, real requirement or anything like that, but you always want to have 2 sensor modalities covering one area. And for example, when you have a radar camera and a LiDAR, then you cover all of these. All right, if it's snowing and raining, the radar should be okay. The camera, not so much, and the LiDAR can punch through it, right? If you have night, the camera's not going to be okay, but then the other two are, right? If you have
So you've got backups and fail safes as well as multidimensional data sets.
Yep. So that I always saw LiDAR as a complementary technology for those higher levels that you were talking about, Sean, which is if you want to get to a level 3 and for sure in a level 4, like I will challenge you to find a successful level 4 that does not have LiDAR.
Right.
They all use it because they see the benefit of having that third sensor modality to cover whatever scenarios, because again, you have to prepare for all of these edge cases that are just crazy and hairy,
So all of that makes perfect sense. And actually, coming from my physics background, this idea of having multiple ways of measuring things is bread and butter for us. But then you move to the discussions around camera only systems, because there seems to be, I was going to say, a big debate at the moment. I'm not sure it is a big debate because it's one company versus the rest of the world.
Right.
But you look at Tesla and they make the argument, and actually I like the argument, that we live in a world designed for humans by humans where sight is everything. So why not create autonomous systems that are as close to human as possible? So conceptually, it sounds great, but from what you've said, there are obviously downsides with that because you've only got one system that you're relying on. How far can we push just cameras?
If you're designing a system to be as good as a human, sure. But we want to design a system that's better than a human.
Love that. Yes.
Right? Yeah. We want to be able to do things that humans can't, right? Because if you even thought about that, right? The human is inside the vehicle looking through windshields. There's B pillars, A pillars in front of you, right? The cameras on a Tesla are not where the head of the human would be, right? They're outside because they want to get the vantage points for all around the vehicle, right? So I think that's a very, look, can it be done? Maybe with a lot of time, right?
Right.
I think that
not with a 4 megapixel camera.
Yeah, right. Yeah.
I mean, I don't know what they're
full of promises.
Yeah. I mean, Tesla, look, they are pioneers in a lot of things, right? As you know, so the system that they've come up with is good. It's just not what it's advertised to be, right? Like an autopilot. It's not an autopilot, right? It's a co-pilot at best. And I think eventually can we get there? Sure, because camera technology with high dynamic range can get really good performance at night. There are thermal cameras out there, that's already in vehicles today, more in a passive way to kind of let you know if it sees a deer or whatever, right? There are ways to get there. I think that a 30 frame per second camera that, let's say even you get to the 8 megapixel, which is top notch for automotive, that the processing power that you need for something like that is very high, where LIDAR and radar, yes, there are calculations that have to be done and other things, but those can be handled at the edge. Yeah. And then the information being sent, it's less to process. It's less power hungry than a full camera image. Now, there are several ways you can slice and dice an image camera and only look of the contours, and there's a few things that you can do, but I guess to answer your question is like, can it be done? Yes, maybe.
To some extent.
I don't think it's ready.
And Brunno,
right now.
I think, the way you said it, I think also sets up, I had pulled up NISTA's web because I was like, we might need this. So I had pulled it up. Yeah. And they have that statistic that, is quite shared, right? That I think this was it's from 2022, but it was 42,514 people were killed in automobile accidents. So when you're saying if a system only has to be as good as humans, that's sort of like the terrible benchmark.
Yes.
Yeah.
And I think that's part of, it's part, besides the advancement of technology, I think that's the humanistic target, if you will, for a lot of these systems is to get that number down to as close to zero as possible, knowing you can, accidents are going to happen no matter what, but 42,000, almost 43,000 if you round up is too many. And so something can be done or should be done and things like that. But I'm going to project what I hear onto what you said. So we need both. We need multiple. We need redundancy. We need extra coverage for these things to properly reach level 3 and beyond, like what we were expecting them to do, to be better than humans, be more accurate, less issues, things like that. Is what's holding it back right now? Is it purely the cost of these? I mean, when you're saying like the cost of moving from like a 1 megapixel camera to an 8 megapixel camera, OEM car manufacturers are complaining about presumably the incurred burden of cost on their end. Are these LIDAR systems and things like that, is that just a deal breaker for most OEMs at this stage to think about a way of being able to incorporate those into, like, I'll say near-term cars, so 5-10 years, that would be in any way feasible from a financial perspective? Or like, what's the state of that? Like, can we miniaturize these things down? Because if you've been into the Waymo, it's a massive bank of tech. If you see our video, I pointed out, it's the same size as the roof of the car, just doubled. It's like a big, thick camping.
And that's only part of it. You've then got the sensor.
And that's only the part that's on the roof.
Yep.
Yeah.
Right. I think, look, the automotive industry runs on thin margins, right? You're looking at,
which is a little hard to believe, honestly, when you see the price tags of these things. $100,000 for a pickup truck.
But think about the capital investment, right? The plants and all of the equipment that goes into it and the labor. So normally, right, like it ranges between, the really good ones, 15% profit margin. Some are hovering 10 or below 10, right? So every cent counts. So when you're looking at, a few bucks of difference, that, let's say it adds $20 a vehicle, that's huge for them, right? So they, in order to stay competitive and not drive to crazy prices like $100,000 a vehicle or a truck, which is there, but, that's what's driving, I think, some of the impedance of getting these kinds of systems there. And that's why you see that it's the luxury models, it's the higher end models of all of these OEMs that have this technology. I think if you look at, it was Mercedes and Audi that had LIDAR, a very rudimentary LIDAR system in their vehicle starting in, 2018 or something like that, right? Then these next generation LIDARs, the first one is the Volvo EX90, right? It's their flagship is the XC90. That's a very expensive SUV 3-row. And this is the electric version of it. And it comes standard with a LIDAR, right? So that's the kind of vehicle that the OEMs can afford to put this technology on, because there are going to be early adopters and people that are willing to pay that were already willing to pay that kind of money. They would pay a little extra to get the extra bit of safety. So, I think cost is what's prohibiting it the most today.
What needs to be done to bring that down? Is this just finding ways to mass produce the tech, or is it more research needed? And is it the hardware or the software? Where are the bottlenecks?
Yes.
Everything.
Well, and I just
all the above.
And Brunno, while you were saying that, I just looked it up, and the EX90, the starting price is $80,000. Right. And that's the start of what you're never getting it at that price. Like by the time you get to the
not
dealer,
the sort of car you buy your teenager.
Right.
Yeah.
But I think it's with many things, right? It's volume that's going to drive a lot, right? So having the commitment from an OEM that's going to say, I'm going to put LIDAR on it. But then like Volvo, they only put it in this XC90 or EX90 that, sells 10,000 vehicles a year. So that's not big enough scale to get the economies of scale working on your favor. So it's really like, having this volume is definitely going to help. I think the continuous R&D of new ways of doing it, I think that's going to help, right? Because then you find some breakthroughs sometimes that gets your cost down, then you're able to, it's kind of like the chicken and the egg, right? Like OEMs will say, I'll put it on when it's cheap enough. And we say, well, it's cheap enough when you give us enough people volume, put it on. Right? So it's kind of a, you have to have some pioneering mentality from the OEMs to say, I believe this is the right way to do this. Let's do a small rollout like something like Volvo's doing, BMW's doing with their i7, which again, very expensive vehicle.
For fun, I'll look that one up too.
So the point is that
play a dangerous game. Which cars can I not afford?
So I think all of that will get it rolling. But the problem is I don't know, how many of these companies will survive, because without having this business, how are they going to stay afloat? Right. So
I guess that's a really weird part of this as well, where if the competition is investing in these technologies and you're not, you get left behind. So it's damned if you do, damned if you don't, if you're one of those companies on the edge.
And the funny thing is that in China, LIDAR is huge, right? Where it became almost a status symbol that if you have that little bump on the top of the vehicle that makes it look like a taxi cab, right? It conveys status. Right. So
interesting.
So China has a very large and healthy penetration of LIDAR technology into their vehicles. Now, are they getting turned on and working? Different story, right? Because again, software, you can always do an OTA, right? Over the air update and
of course, yes.
And get the feature in, but the people want it there just in case. But that's a very different mentality. Plus their subsidization from the government helps those companies.
But this brings another complexity into things, because if the technology is being developed and deployed in China at a time when geopolitics are making it sort of rather complex, sort of exchanging sort of automotive and transport technology around the world, how does this play out? Does LIDAR technology sort of that they're deploying stay in China? Are there ways of it beginning to influence the US? Or are we on our own here?
I think, look, this
would be a great time to divulge any sort of like industry top secret you might be sitting on.
No, look.
Feel comfortable. It's just us three. That's all.
Nobody else listening.
The past 3 years, right, I worked at a company that made LIDARs, and one of the things that we saw was, uncompetitive advantage from the Chinese LIDAR suppliers, right? Where they have subsidization, they have other things that are much more helpful for them to bring the technology at a lower cost,
Yep.
at a loss, right? And then win the business, get all the market share, and then kick all of the
Yep.
American companies, right? So there was, an effort from one of the LiDAR companies that they actually, were part of putting one of these Chinese LiDAR companies in the Department of Defense entities list, because those parts were also being sold to Chinese military. So it was
Right, yes.
civilian military fusion.
Interesting.
So that was Uncle Sam helping, the American industry. And it's not even helping, but it's more like making it more fair, right?
Yep.
Where,
Yep.
And then OEMs, they like to stay away from suppliers that are in some sort of list, right?
Yes.
So then it gets a little bit more true competitive between the European and American LiDAR companies.
Right, yes.
And it
Yep.
makes a more fair playing field. So to your question, Andrew, I think it's going to live in both, because there's some things in place to at least maintain some competitiveness here in the US. And I think the industry will mature,
Yeah.
but it's still going to take time. It's
Right.
going to take time.
Yeah.
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 That's great. And I will point out, I looked up the BMW and it's even more expensive. It's basically just under $90,000 to start. So I'm thinking now what we really need is,
Next year's bonus, Sean.
or just BMW. We'll gladly put Moto Futura all over the outside of one of these beautiful, they could be a sponsor. But Brunno, okay, so I was thinking about this other issue too, that kind of, steers us a little bit differently. With these systems, so kind of let me bring it back down to more affordable, personal situations too. Because again, you mentioned at the beginning too, you were talking about, so while there is like the more advanced ADAS elements like the LiDAR and things like that, in the cars that we're driving today, they're still filled with all of these other sensors, the braking sensor, the lane detection, whatever like same speed,
Adaptive cruise control.
thank you. I couldn't think of the word cruise control for some reason. All these kind of things, right? And I had an experience that kind of triggered this whole thing. I think I texted you about it afterwards. Is we had a windshield replaced, and this system for us and one of the cars, it's inside the car, like inside the windshield at the top, like where the rear view mirror is. And so they, we're like, yep, we got to, out here too, we get so many cracks in windshields from stones and all that kind of business. It's like, yep, got to replace the windshield. And then here's your appointment for the calibration. And I was like, what is that for? And they're like, well, someone needs to come out and recalibrate that annoying
Your
system that you hate. But then I think I was talking to you about that. I think I was just being like, oh, you believe this? I got to wait for this guy to show up between, 10 and 4 on a Tuesday or something. But we kind of had this offline conversation that I think is relevant here to talk about too. Is so we have all these cars currently, and again, as we move the timeline further down, we're going to have increasing cars with potentially even more sensitive, more vital sensors and systems. What on earth happens? So they leave the showroom, they're bought brand new. They have some sort of seal of approval that you bought a level 3 or a level 2 point, whatever. Congratulations, it has all these features. You get in a fender bender. You have windshields replaced. You have, a tree falls on the hood of your car, whatever. Those systems are disrupted, replaced, damaged. They melt. I don't know, whatever happens to them. What happens then? Like, how do we because that to me feels like a major concern. And I don't know if you can share the numbers, but I remember you sharing with me a number of people who never get those systems recalibrated.
Right. It's scary.
Yeah. What do we do? How does this work?
It's a hidden threat to road safety, right? Because you're absolutely right. You have something happen to your windshield or your bumper, usually where your radar is located, and it goes through a body shop repair. And those repairs, then you need to recalibrate the sensors. Now, there is a vast lack of education in this aftermarket service industry where they don't know, because a lot of times the vehicle will not set codes, right? And one of the ways that shops know the car is good to go, there are no DTCs, right? So
and you're talking about whether they hook those the computer, like the check engine light stuff, right?
It's a scan tool on the OBD port. And, these diagnostic trouble codes, DTCs, that's a flag for them to say, if they scan and see nothing, they will just ship it, right?
Yep, good to go.
Where, there was a study by IIHS that showed that if a camera was 0.6 degrees off. It reduced the reaction time, the automated braking reaction time, from 3.4 seconds to 0.9 seconds. And the vehicle crashed into the dummy target.
Wow.
Right? So just 0.6 degrees. So think about any, accident that could have moved that slightly, 0.5 degrees, 0.6 degrees. Your radars, whatever fender bender you had, those sensors a lot of times don't know that they need to be calibrated. They don't tell the technician. So, and, it was, there was a report by a company called ADAS Think, and they, that said that 88% of 100 vehicles that they probed that they knew needed calibration did not get calibrated.
Wow.
So if, let's say we extrapolate that to the whole, crashed vehicle, in the United States, right?
Yep.
You're looking at all of these millions of vehicles that have been into an accident, got repaired, the person gets it back and thinking that their vehicle is fully functional, and it's not.
Right.
Sure.
Right.
So that's one of the things that is super dangerous that, in this new role that I have with the Ascential Technologies, right? We do focus, in the aftermarket, and we do take a look at that. And I just started peeling the onion, and I started looking at all of this data and all of this, the number of vehicles not being recalibrated and the impacts of a vehicle not being calibrated. And it's just it's a hidden little secret that nobody knows about.
That's crazy, and it feels like another phase of vehicles, cars. And I'm just thinking back, because I remember very distinctly when we went from the car that you could maintain yourself. You sort of had the carburetor and everything. It's if you learned a bit of mechanics, it was easy. Then we went to these fully encased systems where with all the sensors where you just couldn't do stuff. But now you're getting to a third stage with all of these sensors where you don't even know what you don't know. And this is actually worrying me quite a lot now. I wish we hadn't had this conversation, because I'm thinking about all of these things that I hate but rely on. They just need to be a little bit out. And how would I know?
Yeah. Well, instantly I'm like, instead of a check engine light, there needs to be a check sensor light.
Right. Yes.
And Brunno, I don't know if you know the answer to this, but who creates the regulations for needing those codes? Is that a self-policed OEM? They just agree to do this, or do you know? I don't know if that's something.
There's a very loosely regulation around that, where there are some things that right to repair cause the OEMs to be forced to do a few things that allow you to read certain things on the vehicle bus, right? The CAN bus or the Ethernet bus or whatever. So no, it's like NHTSA, Department of Transportation. A lot of times, if it's aftermarket, the states are responsible for some of this, right?
Interesting.
You see Maryland,
it's frightening.
And 2 other states already have some sort of regulation that said, hey, this stuff needs to be calibrated. Right?
Right. But you can also imagine, you know what people like with check engine lights. The number of people out there who say, it doesn't really matter, I'm just going to drive anyway. You can imagine somebody getting a sort of a warning that says your radar is 0.6 of a degree out. And they're thinking, who cares? I'm just going to drive anyway, because they won't understand the consequences of that.
Yeah. Well, and Andrew, that would be a good improvement already.
Yeah.
Right.
Like, there is nothing like that.
Well, nothing at all at the moment. Yes.
And I'm even thinking now of people, right, like who haven't even been into an accident that requires like collision repair or something like that. You drive into like a parking garage, or if you go through any like drive through and you see those poles everywhere, they're scraped up beyond belief. So someone's hitting those things. Right. And and especially I always think of like the parking garage ones. That's a slow like grind against the wall. And so even things like that where you do that, but you're not going to an Autobahn. Well, I shouldn't say that, but I can imagine a scenario where you do that. You're like, I'm just not going to say
a little ding. Yeah.
You're backing up and you're like, boop, oops, no damage. But it would be enough to potentially throw off your sensors or whatever, technology that's in there. So, and you wouldn't even think about it.
Yeah.
You wouldn't even know.
I'm going to ruin your day a little bit more.
Oh, no.
So let's, again, looking at that one report, which is a small data set, but it's something. assuming that only 20% of vehicles are getting calibrated, there are really bad calibrations out there. Okay. So there are, even out of the ones that are getting calibrated, I'll encourage you to read this if you want to fall asleep. But if you look at, calibrating,
we read these kind of papers all the time, Bruno. It's okay.
No, this is documents from the OEMs that tell you how to calibrate the sensors, right? And it's literally plumb bobs and tape measures, okay? That you have to, just show up, measure, and make sure that, you kind of got it I think I got it right. And then they'll calibrate the cameras
good enough
and the radar.
approach,
Yeah, based on that, where that it's on itself is already dangerous because, again, the 0.6 degree that we talked about, you can calibrate a sensor that's off by being off again when you calibrate, and the sensor is almost as bad as not being calibrated.
Right.
So that is one of the things that, again, you have to have some level of, at the very bottom level, right? A mandate that, hey, vehicle gets into an accident, you shall calibrate it. But number two would be a standard to be followed.
Of course, yes. Yeah. And that's where I was going to go, was it almost feels as if these systems are seen as optional luxury items. So if you've got sensors that allow the car to auto brake or whatever, and you see it as a luxury thing for luxury cars, you can imagine people thinking, if it goes wrong, it's just one of those luxury things. Whereas it seems like there needs to be a mind shift where we see these as essential safety features.
Yeah. Safety is not a luxury.
Yes.
Right?
Yeah.
Right.
At the end of the day, safety should not be a luxury, and we should be democratizing these life-saving technologies, right? And that's one of the things that the 2029 NHTSA mandate does, is make it standard, right? So now it's a standard thing that every vehicle is going to have. And then, because I told you, these are sensors at, higher resolution, and they can do more. And those usually, and again, it depends on the OEM, it depends how they do it, but that's a lower level fusion, meaning I'm not letting the sensors do the object detection classification and then I do a high level fusion. These are extremely aligned with each other and detecting things at the same time in the same field of view. Which then makes these calibrations even more important.
Goodness me. No. And that's the point where you really scare me, where you've got multiple sensors that have to work together in synchronicity. So yes, I can see exactly, you get even slight misalignments there and everything is up the chute.
Off, right? And, and then we go back to, again, this has been AEB front facing, right? Yeah. Then you get to the level 2 and level 3 features that, you have now most of those vehicles, let's say one camera, one radar, right, for front facing. And then they usually have corner radars for your blind spot detection and other things, right? Yeah. Then you go into these level 2, level 3s, you're looking at 8 cameras. Yeah. You're looking at 7 radars, 8 radars sometimes, and you're looking at 1 LIDAR. Right. So then all of those
complex systems. Yeah.
All of those have to be completely aligned and calibrated in unison.
So here's a question for you. Does technology currently exist, or could it potentially exist, where these sensor arrays self-calibrate? That is, they have the ability to detect their environment and actually sort of measure their performance against each other so they can see whether they're off or not.
In today's vehicles, you already have some of that, right? Where there is normal wear and tear of the vehicle that's going to cause it to sag or do something or change, where it's constantly tracking that, right? So there is technology there for both cameras and radars. Yep. It's when you get to these events of a collision that your datum is completely changed. Right.
Yes. Yep.
And then that algorithm is not capable enough to recalibrate by itself. At least in today's vehicles, there is some work that I've seen done that it could enable it to be better in the future, but there is still this baseline that needs to be drawn in order for the vehicle, the sensor, to know where home is. Right. And then to make that distinction. Am I off or, so, and as the sensors get, higher resolution and everything, it gets even more, difficult to do a dynamic versus having these needing a calibration or not. So it's not out of the question, Andrew. I think it's I think that we already see it today. It's just not to the level where it would self-calibrate after
after an issue.
Right.
Because that's one thing I was wondering too, right? About and maybe again, Bruno, let me know how much of this is fact or fiction. But this direction, right, or at least something we potentially, from someone who's not in the automotive industry, would think might be very compelling is you have all these systems, and then each of those systems has its own intelligence, if you will, and then there's like the car, whatever, the supervisor or whatever. So like an AI system or something of that nature, an automated system that is sort of like the car's AI system that talks to all these other systems, sort of in this sort of like community way of knowing like, oh, we've got a problem over at front bumper left or whatever. But front bumper right's working, and you know what I mean? Is this just fantasy that we would have like I envision?
Are you talking about V2X, like vehicle to infrastructure, vehicle to vehicle, or are you talking about
internal? I was just thinking more internally, like for example, I step into my, what was it? Some fancy, the BMW that they give us as sponsorship. I set in there and it says, "Good morning, Sean. All systems are performing now." So it's my own little enterprise. It's my own spaceship.
Like your co-pilot doing all of the checks.
Where I can say like,
yes.
"Computer, tell me what's going on with the whatever, the left-handed smoke widget." And it says, "Well, it's performing optimally today, Sean." Is this something that is part of that system design, or is this just wishful thinking?
No, I think that, so that's diagnostics, right? That's what it's called. And those DTCs that we talked about earlier, right? Those are the ones that raise their flag and say, "Hip, I got something off," right? I can't see, but again, a lot of times it has to be something egregious for it to detect that something is super off. If it's off by, like, again, the 0.6 degrees, it doesn't. Yeah. Right? So those are the things that, yes, that technology exists, Sean, and I think it's only going to get better.
Okay.
But that also adds cost because you're adding sensors within the sensors to detect failures.
And potential points of failure, right? I mean, it's like, as the complexity continues to increase, the chances of something going wrong also increase, right? With that.
There are like different levels, right? It's called ASIL. And I forget what it stands for, right? But it's basically like these safety ratings, functional safety ratings that, it's American. No, that's different. Automotive safety integrity level, right? Something that's ASIL B, D, B of D. There's a bunch of different things. But like a D is, I need to be able to detect everything that's wrong with me. And that is, like a L4 system needs to be ASIL D, as in dog. Then B is like, I got some stuff, I can detect this.
I can tell you. See, this is what we need. I want a sassy car that talks back that I can talk to. I'm like, what's this check engine light for? It's like, don't you worry about that. I've got it under control. You can make it home in time, versus like, you need to pull over.
It's a little iffy, but you should be okay. Just be a little careful.
This is because of your driving style, Sean. Like, maybe go a little more easy on the brake.
The ASIL A's and B's is more common because, hey, I got some things that I can talk to the main computer to say, I got something's wrong, right? Diagnose. And that includes a million things, right? Losing vision or detection, losing communication, losing, there's so many failure modes, right?
Sure.
And that's where DFMEA comes into play, right? But then whenever you go into like a level D, you're talking about a massive engineering undertake, which is going to add so much cost to it, right?
Yeah.
Which then, to our previous conversation of these sensors being cost prohibitive and doesn't make financial sense for OEMs to do it, right? So it's a balance, right?
Yeah.
The technology does exist to your, future of sitting in a BMW and asking, what's wrong. But
whether it's economically viable.
Of course.
Yeah.
I mean, we anthropomorphize our cars all the time anyway, so it'd be great if it had a personality.
Yeah.
be like, get Marvin, the car.
But you can imagine. Just thinking, where we've come over the last 100 or so years with transportation, you can sort of see that early sort of shift over to sort of vehicles with the fairly basic internal combustion engines. But we're now talking about advanced AIs with a set of wheels on them. I mean, that's how far we seem to be going.
Yeah, there is I forget, like, again, this is years ago, but the Chevy Volt had something like 10 million lines of code, which was
Wow.
10 times X what previous vehicles, like it was just
Yeah.
something insane where, that was deterministic code. Right now you're looking at these large language models. You're looking at, CNNs, DNNs, and other neural networks that, are running things kind of in a black box way. Which is again,
they're already black boxes to most
Right,
non-mechanically inclined folks anyway.
But, that causes like when you asked earlier, Andrew, about the liability, right? Something like that happens, and it's a black box,
Right.
Okay,
Yeah.
So what happened, right? They don't know, but there are advancements in that. There is, of course, this AI push, right? And
Yeah.
I think it's only going to get better, but then again, you need that kind of cautious approach. Especially when you're involving the public and bringing these technologies. And I think near to medium term, ADAS, meaning level 2s, level 3, is really what's going to dominate the market.
Yep.
And then you have, the Waymo and the Waymos and these Zooks, because again, they got deep pockets behind them that will keep chugging along until they get it. And then once they get it, I think, there's a paradigm shift of, I remove the driver, which is the largest cost of an Uber and a Lyft. And now I can, if I'm profitable, then they can just scale, right?
Yeah. And other people can copy that model then too, right?
Yeah.
Well,
so I realize we probably need to wrap up, but one final question going off from that. So Tesla's robo-taxi sort of concept. So everything you've described makes me think that this is still pie in the sky, something that is aspirational. So do you have a hot take on whether Tesla will actually have these robo-taxis on the roads in a few years' time?
Was there a promise made with that debut? Did they say 5 years?
It was an Elon Musk promise, which I think is sometime, maybe.
Yeah.
Well, I mean, look, they promised robo-taxis in 2020. If you recall that,
right? Yeah, there's supposed to be there's supposed to be an over-the-air update for your Tesla, right? To make it into a the Airbnb version of a robotaxi.
I mean, I like to look at the facts, right? So let's take a look at that launch event, all right?
Yeah.
And then you look at it's a Hollywood studio, right? Like
I've been there. It's great. A lot of movies and TV shows filmed there. It's great
streets, right? And the vehicle comes in and comes out like autonomously, allegedly, right? So it's I personally don't see it happening anytime soon. I think that the approach that Waymo took, right, which, they just passed Lyft in San Francisco as, doing more rides for the first time ever, which is a huge.
That's
right?
pretty amazing. Yeah.
They're going to Tokyo, right? So you started now seeing Waymo push their implementation more, probably because on the technical side, I think they're really solid, and maybe they're making inways with the cost, right? To make this an economically viable option, because if it's not, the more they expand, the more they lose money. I still think it's more of pie in the sky. For Tesla, I don't think they're going to be able to do what Waymo did, or be at the level that Waymo is without the sensors that they have, and all of the millions of miles of testing that they did. Tesla has a ton of data that they collected over the years, but that does not mean that they've been testing autonomously. They've been vehicles being driven. So,
and again, it comes back to that sort of difference between what you can do and what you can do safely and responsibly.
Yeah,
right.
Well, and to me, it feels like again one of those sort of carrots on an ever expanding pole that you just never get close enough to, right? It moves away from you at the same rate you move towards it.
Yeah.
But also, if I remember their business model correctly too, they were pitching it as like, you, the consumer, can buy this car as a business investment because it'll make you money. But I'm like, but they're neglecting also like the upkeep, when you run a fleet of taxis, the driver's only one cost. It's all the maintenance, insurance, all that stuff too.
The sensor recalibration.
Exactly.
The Tesla robo-taxi.
Exactly.
Yeah. I mean, when you think about that, right, their proposal was like, you buy it as your vehicle, and then you spend 8 hours at the office, you just let it go, hail rides, and you make money, right? So it's an appreciating asset. It's a revenue generating asset, right?
Yeah.
And you're right. I mean, look, the electric vehicles on their own have trouble because they're so heavy, right? And their tires don't last nearly as long as a regular ICE, internal combustion vehicle lasts. So you're going to have that problem. And then everything else that goes with it, right? Like all the wear and tear.
Wear and tear. Someone throwing up, someone puking in the back of your car.
Like
right?
someone
getting car sick,
I think
who's cleaning that out?
Like, I think it's a cool idea.
Yeah.
Right. I just don't think it's close to
with
being
a
reality.
Yeah.
It sounds like, Andrew, you're gonna have to hold on to that dream until the robo humanoid comes with it.
That's right. Yeah,
to clean up after whoever's
we're going to have the Tesla bot actually driving the car and cleaning up after the passengers before we get to the fully autonomous.
Yeah, and this will all go around. He's basically just created Johnny Cab from Total Recall.
There we are.
And there we are.
Full circle.
Oh, this has been fantastic. What do you say? Should we pull this episode into the garage and park it?
We'll see with that metaphor. Yeah.
I held out so long.
Right.
You had so many on the Waymo episode, and then now you hold back?
I know. Well, I get it.
You used them all.
Yeah, it's terrible. I ran out of them like you'd run out of gas.
Andrew, I'm sorry you have to put up with them.
It's a labor of love.
Oh, goodness. Well, Brunno, awesome. Again, Brunno Moretti, thank you, my friend, for joining us on Modem Futura. This has been an absolute blast.
Yeah, thank you so much for having me, guys. Awesome talk.
Yeah, well, and I mean, honestly, we got through 20% of what I had my my notes. So, this is a conversation I think that will be forever ongoing as these technologies and things unfold. And maybe some other time we'll get to talk about a little bit too about, you had mentioned it briefly, this car to infrastructure communication, because I think that's another wave of advancement that I think hopefully will be maturing along with the pace of some of this innovation that we're seeing. But yeah, fantastic to have you on here, my friend. Awesome. So much fun.
So glad I could make this.
Awesome.
Thank you.
That's I have one thing to read here as a special note, because I almost forgot and I got it, but I wanted to make sure we got in a special acknowledgement. And so from us here at Modem Futura, we'd like to acknowledge the partial funding support provided by the U.S. Department of Transportation sponsored Travel, Behavior, and Demand National University Transportation Center, led by the University of Texas at Austin. The center, of which ASU is a consortium member, has helped make this podcast episode and the research we're discussing possible. So
thank
you. Put that in there for good measure. So thank you. Brunno, again, thank you. Give my best to all the family.
Will do.
And Andrew, fantastic as always. Thank you.
Yep, same here. Good to see you. Good to see you both.
Yeah, and so I'll drop links to Brunno and to as much of the car tech as I could find. I'll let you do your own searches for the fancy cars. Let you just stumble upon that yourselves. But from us at Modem Futura, thanks for listening, and we'll see you on the next one.
See you.
See you.
Demodulating signal.
Modem Futura is a production of the Future of Being Human initiative at Arizona State University. Be sure to subscribe on Apple Podcasts, Spotify, or wherever you listen to your favorite shows. To learn more about the Future of Being Human initiative and all of our other projects, please visit us on the web at futureofbeinghuman.asu.edu.
End transmission.